All right, so let's quiet down, please, please. Let's see. We are so the last couple of weeks we've been talking a little bit about some theoretical foundation on talking about how to model, how to represent data, how to structure it, how to break it up into multiple entities and relate it amongst each other, mostly using the UML class diagrams, right? And we were introduced it as a very theoretical, very conceptual way of thinking about data, irrespective of how we want to be able to actually store it. Right? So one issue is actually storing it. Another issue is representing it conceptually. In one particular way that we're going to consider how to store it is relational databases, right? Which is going to be the focus for the next couple of weeks. And we've already introduced some of the concepts of tables and rows and primary keys and foreign keys. We already made some inroads into that topic. But one is very specific framework on how to store and retrieve and represent data using relational database, whereas UML class diagrams is very conceptual, right? And we've seen that conceptually we can transform that conceptual model into any number of representations. You know, one of them being using object-oriented technology, using object-oriented languages, using XML where you have all these hierarchies, graphs. We have all different ways of storing this. But in particular, we're going to spend a couple of weeks using the relational model. Okay, and we also mentioned that regardless on how you decide that you're eventually going to store this and represent this in a physical format, you're always going to run into the same kinds of issues, right? On redundancy, trying to avoid inconsistency, how to break it up from one big representation into multiple data sets, and then how do you maintain relationship between them. In a relational model, we've seen that typically we implement that using foreign keys and primary keys, and we use referential integrity to enforce certain constraints between the records that are related to one another. Right? But instead, if you were using object-oriented technologies, there's no such thing as foreign keys and primary keys. It's mostly all implied. It's all hidden from you. There's all these pointers pointing to each other, represented by abstractions such as lists and collections and sets and hash tables. You know, all these are conceptual representations of some underlying representation in memory and pointers referencing each other. Right? If you were instead using XML to represent the same UML class diagram, you might be using some kind of hierarchy of some tree where you have a root and then you have many branches, and this hierarchy represents the one-to-many and many-to-many relationships between the different data structures and different data sets. Yes? So each particular way that you physically decide to represent this has its own quirks, has its own ways, very specific issues on how to actually implement it, but nevertheless, they all deal with the same problems of redundancy, inconsistency, of breaking it up into multiple constituent data sets that are somehow related to one another. Okay? So again, we'll look at data modeling using Java a little later, we talked about UML. We'll talk about relational database for a while, and we'll see that mapping the ideas of a conceptual UML class diagram doesn't necessarily map directly to something physical that can be implemented in particular in relational databases, right? For instance, we mentioned things such as inheritance, for instance. It's not fully supported, right? It's not supported at all in relational databases. Nevertheless, we need to find ways to actually represent it, right? The fact that you have these base classes and derived classes and whatnot, nevertheless, we need to find ways of representing it. We'll look at three ways. There's three particular ways that is very common to represent them in a relational database. Obviously, if you're using object-oriented technology, the programming language already have the syntax, to represent the idea of inheritance, right? And have keywords such as extends or interfaces for implements and so on and so forth, right? Many of the ideas of object orientation, when folks were inventing this up, never made it into any languages, right? There's some ideas that never actually made it into being implemented into any particular framework. We've spent quite a bit of time already on how to break it up and all the conceptual foundations on data structures and the structure of data and relationships between them. The next couple of weeks we're going to spend on how to represent that conceptual model into a relational model, specifically using SQL for creating tables and querying it and updating and deleting it. And we'll talk about views and triggers and how to program the database from within the database. We're then going to step away a little bit and see how we can map this relational model into an object-oriented model, right? And so that we can start integrating it with object-oriented programming languages such as Java, and being able to integrate with the database programmatically. Specifically, we'll take a look at the JDBC, how we can programmatically talk to a database. Once we've implemented some of the best practices using JDBC, we'll note that there's actually already some of these best practices that can automatically be generated for you without you having to do it by hand. And so that will introduce the notion of object relational mapping on how to map these two worlds. And then we'll have the midterm. The other class is going to have a day off on Monday, the 8th, I believe. Right, so we might get ahead of them a little bit on that week. All right, any questions where we're going? Probably not. Right, probably not. Yes. Yeah. Yeah, that's gonna be challenging with the other classes. But we're trying to keep them all at the same pace.